So this first slide is something you might have seen earlier in TNFL 01. So this background and in general this whole first slide is from TNFL 01 lecture that Tobias used to give, and I will reuse some of his slides. I don't know if you saw them with Cristiano or not. You can read. Okay, so thanks. Yeah, I read the chat. Fine. Anyway, so you might see a mix of slides from Tobias. As usual, I will be using slides from MIT from a different course though, not airline management, but economic mechanisms, and you will see those slides too, and I'll mention them. So here on the slide, you have a figure from our textbook. We mostly don't use the textbook, but if needed, I'm bringing the relevant material from it. It shows all processes in an airline. So in this picture, you have on top, you have some of the things in the strategic phase of the planning, and then we mostly study things in the tactical phase, which is fleet assignment, and then we'll go through aircraft routing and crew planning. And revenue management sits here in the planning phase, but it has input from the strategic phase, more specifically from demand forecasting and modeling. And we will speak about demand forecasting and modeling in a separate lecture. And revenue management is also used in the operations phase, right here when we look at the seat inventory control. And this is actually something into which we go in details, how to do the different seat types or class types in an aircraft. But I guess this is the first time when you see the picture with all the processes of the airline. We will have it in the overview lecture, but basically what you need to know now is something that you might have realized otherwise, that there is strategic phase, planning phase, and operations phase. And well, we are looking at the revenue management, which kind of spans more or less all three, but we will be mostly looking at this seat inventory control. Okay, so well, airline wants to make money, surprise, surprise, and of course the profit that you make is the revenue that you get minus the cost. But in some sense, in the tactical phase or in the planning phase, when your routes are already decided, when you have committed to flying certain routes from origin to destinations, in some sense your costs are fixed. Why? Well, because a lion's share of the cost is the fuel. And fuel and the personnel cost that you will have to incur kind of no matter how many passengers fly your aircraft and no matter what classes of passengers fly your aircraft. So we speak more about it in TNFL 10 in air traffic management course, but I will mention it already now because what happens these days, or well, happened about a month ago, when the airlines had a decrease of demand, we still had flights over Europe flying back and forth, probably empty. I mean, we don't know how many people there are on any aircraft, but a lot of aircraft were flying their routes just to keep their slots at the airport. So in Europe, we have this grandfathering rules for the slots in airports. If you use your slot 80% of the time, then you can use it next year. It's your slot. If you use it less, then you're going to lose your slot. There is some secondary market for the slots and so on. So the airlines had to, well, fly the airplanes probably empty just to keep their slots. I guess they relieved this a month ago or so that they don't fly more than necessary. But in any case, what I wanted to say is that if the airline flies the aircraft, the profit maximization is really about maximizing the revenue. Of course, the cost depends slightly on how many passengers you have, because you maybe use less fuel, but you still have to fly. So we will be talking only about profit maximization, not really talking about the cost here. We talked only about the cost in the fleet assignment because, well, the cost depends on what kind of aircraft you assign. But here we will talk about the revenue part. So the objective of revenue management is to sell the right thing to the right person, the right price at the right time. Let's look at some of the details of what does it mean to sell the right product, what the product is, price, and other things are. So the product that an airline sells is, well, space on the plane, either for passengers or for the freight. And again, to echo what we just talked about, this thing that the airline sells is a perishable product. It's gone if not used. So there are other types of perishable products, and if we had face-to-face teaching, I might have stopped here and let you think what other perishable products we have. But I'll spare you that. Well, there are quite a few things that have expiration date are such, but maybe most related are the show tickets or any kind of events, tickets to any kinds of events. Well, you have to have the event irrespectively of whether people come or not. Well, unless you cancel or whatever. So this revenue management type of question that we will look at for the airlines are also very much related to event organizers. They also have different classes of well, tickets and prices for tickets and different classes of customers. Even though it's not as specific, if you buy tickets for a concert, you just see, well, depending on the seat, they cost differently. So you're not called as business class or whatever, spectator, or not that I heard of. But this is still very relevant question for the event organizers, how to sell the right number of tickets to the right people at right times. So returning to the revenue management for an airline, well, yeah, it's a perishable product. And so we know what the airline sells and to whom it sells. And the price, well, in principle, the price should depend on the time. You know, you might have seen it, how the prices, well, mostly grow closer to when the aircraft is about to fly, but sometimes also go down. I mean, I've seen it also in other modes of transportation. For SEA, sometimes you can get, you know, a ticket 1 hour before they realize that they haven't filled the train, and it can go down. Anyway, so there is this question of how the price should change with time, you know, this graph. But we will not be concerned with this in this course. That goes too much into the economic details. So we'll think that prices are fixed. More importantly is that we will be looking at different kinds of customers. Very specifically, we will be looking at just two kinds of customers, business and leisure, second class, economy class. You can have different names for them, but two different classes of people or passengers. And there are various things in which they differ. In particular, you can charge business passengers a higher price, but they need convenient schedule, they want fast connections and other things. They spend less time at destination, like going back and forth. Most important for us will be that they don't book in advance, or don't have to book in advance. You know, there is a need for a business trip arises, you have to go somewhere. Well, even for a scheduled meeting, you can decide last minute, or if you have to go repair something, then well, you know, you go sometimes as early as 1 day. You book a ticket 1 day in advance. The leisure passengers are opposite in this sense. They do care about pricing, and they want to book longer in advance. They plan their vacations, something more serious than just a 1 day business trip. And here is a slide from the MIT lectures. So here at the bottom, I have the link to this lecture slides. Again, this is a different course. This is not the same course at which we looked when we were doing the fleet assignment. There we have the blue background slides from Cynthia Barnhart. This is from Petra Belobaba, also from MIT. PODS, here at the top you have PODC, is their system that they're using at MIT to study revenue management. We don't have it, but you will see some references to this PODS. The references are irrelevant, but a lot of things that they talk about are, of course, relevant to us, and, well, essentially speaking about the same things with slightly different languages, and it's the language difference that I want to emphasize here in particular on this slide, so that when you see things like this elsewhere, you understand what people are talking about. So going bullet by bullet, so this time of day demand and schedule tolerance, it's a fancy name for saying that different customers, different people, different passengers have different tolerance towards demand and schedule changes. In simple words, it says that business passengers care about the schedule. They really want to fly at certain times, while leisure passengers can shift their plans, plus or minus a couple of days if necessary, or maybe even a week, if it's a summer vacation, whatever. So that's a fancy name, and the first bullet, fancy name for that. Maximum amount of pocket fare willingness to pay. Again, as far as I understand, I didn't talk to the lecturer in this course, but this is just a fancy name for saying that business passengers are ready to pay more. So we will have a higher price for a business ticket. Yes, and this attributed cost associated with different changes in the itinerary. This is more related to the demand modeling. We will look into that, and we will have these different coefficients associated for different people with changes in the price, changes in the trip, path quality, where path quality will have some specific definitions like the distance flown or the time, number of connections, and other things. So again, it says that people value these different properties of the flight or the itinerary in different ways. Different people care more about, some people care more about path quality, others about some restrictions, and so on. And now here at the bottom, you have this maximum willingness to pay, again, the price that the people are willing to pay in simple terms. So we will have these prices as fixed. So we will assume that we know how much we will charge from the business and leisure passengers. And this says that, well, in principle, it has some distribution, and you may work with the distribution. We don't do that, but at MIT they do in this EPODS system. Okay, so continue with the revenue management. We want to maximize profit, and here is the catch. So essentially, this slide shows what the problem is, or what the challenge is, that we want to sell more business tickets, but we don't know how many business passengers will want to fly our flight because they book after the leisure passengers. So if things were vice versa, if first the business demand would come, then of course we would serve all the business customers, and then the remaining part of the aircraft would be sold to the leisure passengers for the smaller price. But really the catch here is that the booking is done in the opposite way, and our goal is to reserve certain number of seats for the business passengers and sell fewer tickets to the leisure passengers. And that's essentially the goal, to understand how many seats do we need to reserve for the business passengers. So the idea is that we reserve some part of the aircraft for the business, the rest goes and gets sold to the leisure passengers. And then if later you reserved too much for the business, well, you lose profit because, well, leisures don't book last minute. assumption. So that's the general challenge, and I'll pause here for a few seconds to take any questions that you have about that. Okay, so few things about a few words about how things are done. Yes, as I mentioned in this general theme, there is some demand forecasting that comes from the strategic planning. The airline is trying to understand how many passengers of different types will want to fly each of its origin destination. Market here means origin destination. Yes, the pricing will be the input again. How much to charge is kind of outside of the planning phase. And seat inventory control is exactly what we will be looking at. So this is what we will be doing in this lecture. And we will assume that this revenue management is implemented separately for each flight. We can update yes, the decisions as often as needed. We can solve this and resolve this problem every day. But we don't really take into account that, that in many cases, an itinerary has several stops. And so, yeah, implementing it for every single flight, it has certain limitations. But as usual, we split the problem into simpler one and then trying to solve the simple one. And then maybe somebody else will do this kind of what they call network optimization, where you do the seat reservation for the whole itinerary. And different people come to different flights from different connections, so that's much more complicated. We will look at one flight only, right? So demand forecasting will be, demand modeling will be later. Now we look at this seat inventory control. Just a few words about the pricing, how it can be done. As Tobias had in his lectures, in TNFL 01, at least with Tobias, now students looked at what's the lowest that the price can be. Again, you still have to pay for the consumables. Of course, what the optimal price is, because the general answer is that there is no single value. And now again, we're looking at MIT slides. So what again? I guess they have just fancy names for simple things. Well, maybe that's why they're MIT. So differential pricing means that yes, you have different prices for different classes of service of passengers, or different fare products. And here they say in the third bullet that almost all airlines, they do have these multiple pricing options. It used to be the time that the low fare carriers, the low costers, well, not only that they had the simplified fare structure, they just had a single fare. No matter who you are, you just pay 20 or 50 euros for the seat, and you fly. That was 5-10 years ago, from my experience at least. And now, even with the low costers, well, at least Ryanair and Wizz Air, which I use, I guess others also do that, they do have various fares, even if they don't really have the different classes on the airplane with different distance between the seats and so on. They do have different fares based on whatever luggage or other bells and whistles that they attach to the ticket. So this simulation and diversion are these kind of two competing things. Stimulation, so you can stimulate new demand by lowering the prices, but you should be careful not to divert people. If you lower the prices too much, then business passengers will say, well, if the economy ticket is 10 times cheaper than the business ticket, then maybe they would go into the economy class. And yes, I'm not sure what I could cite for this last bullet here, that some of the difficulties were due to diversion of the revenues. Well, believe the MIT lecturer on that. Okay, so speaking a bit about the classes, yeah, I kept animations from Tobias slides. I don't know how much they make sense. The animations when we do the online teaching. Yes, so there are um, quite a few different classes. And Tobias lectures, which I guess are a bit older, they say that yes, for the low costers, there is a trend to have the same uh, prices. I guess that has been changing. Even them, even the low costers do the price differentiations. Yes, it does make sense to speak about the assigning different kinds of seats to different classes, because the capacity of the aircraft may change very, very much. Of course, our favorite example in the airline management course is the huge, the jumbo jet, the A380. It can have various classes. You can have A380 with all economy seats. I don't know if any airline has that, but of course you can also have business on the second floor, and you can have more and much more. But interestingly, the number of seats that you can get varies quite a lot, right? So there is a good question: how many seats does 380? Yes, it can have as many as 800 seats, but if you have three classes, it only has only quote unquote only 500. But if you do all economy, it can be yes more than 850. So 300 extra seats, it does make a difference. You do have to think how many you want to uh, reserve for, well, different classes, but in particular for business passengers. Or if you, okay, of course, it's a huge aircraft with hundreds and hundreds of seats, but it also gives you the understanding of the relative sizes of the possible classes. Well, you can, well, not double, but you can increase the capacity by a factor of 1.5 or something. I mean, after all, it depends on the distance between the seats and also how many seats you have in a row. So, and yeah, very often we don't even really speak about the physical seats, but we really speak about how many tickets we should reserve for higher paying passengers, well, or giving them some other, I don't know, better service or whatever it is. Yeah, so some examples again. Here I'm using an example from Tobias. I'm not sure from which year he had this 28th of October. So, but the important thing is that the ratio, the price could differ by a factor of 10. And as we will see, it is indeed not the absolute value of the prices, but their ratio, what business passenger pays to what the economy or leisure passenger space, is the ratio which makes sense, which determines the optimal seat reservation level. So I have my own input here. I don't know if you can see, but I was just booking at the wonderful times when we had the flights directly from Norrköping. I was flying to Munich a lot. I just noticed this, that economy was more expensive than the business. I have no idea why that happened. It was interesting, so I saved it. So different price. Okay, so we still have 15 minutes in the first 45 minutes of the lecture. Let's get to our business. So we know what seat reservation is about. We want to save seats for these passengers that come later but pay more. And let's look at some of the details. Problem statement. So we know the capacity of the plane. It has been decided, from the fleet assignment. So we know what fleet type we have. We know the price. So somebody told us the price from another department. You defined it earlier. Somebody told us about the demand per class, how many we may have of the business class, how many we may have of the leisure class. We'll have a lecture on that. And we want to understand how many seats we should reserve for the different classes. So this is kind of not fully formal problem statement, but at least we are trying to get to this bulleted list of what we want to have in the input and in the output. So for the capacity, we will assume that we have 100 seats on the plane. And it really doesn't matter whether it's realistic or not. It works for an airplane of arbitrary capacity. So what we really want is to understand the fraction of the seats that we reserve for the business class. 100 is okay. I think there will be one of the problems on the homework where you have 90. Okay, we'll work with 90. But for the lecture, we will work with the plane with capacity 100. So we will only consider two classes, leisure and business, even though in general, of course, well, there could be more classes. So what we will be doing is we will be looking at the so-called nested booking. Okay, so saying there, yes, I see the comment that there is a flight. Yes, so from New York to London, something that uses only business. Yeah, I wonder when the supersonic was the Concorde was in operation. Well, I guess the price was large. Don't remember. So I actually saw the Concorde back in 2002 or something. Standing at Heathrow. So I was a student in New York, and I was flying back home via London. I saw Concorde parked once. It was 2002 or something like that. It was a small one, and I did check the tickets for it, thinking, well, okay, maybe I'll fly the Concorde once. I think it was a few thousand dollars at that time. And you say, okay, BA1, yeah, Shannon, there, and now A318. So this is true. There are airlines that fly only business. I forgot what it's called. I think it's called Midwest. There is an airline that flies somewhere in the Midwest US. It has only business seats, so to speak. All of them are leather and so on. JetBlue, well, that's quite a big one. It has its own terminal at JFK. It flies. It has only leather seats, and it has the TV in the back of every seat. And it used to have it even in 10, 20 years ago. I think I flew it in 2005 or something. So it was also kind of business only. Yes, there is a big demand. Yes. I mean, if there is a demand, then yeah, things are easy. We just reserve everything to the business passengers. So right, but here we considered just two classes. Nested booking. I wanted to draw what nested booking means, but I seem to have lost the annotations on the screen. But anyway, I will share the screen from my tablet and draw things later. And also in the MIT lecture, we will speak about this nested booking. So what it means is that if you have several classes, instead of deciding separately how much you want to keep, how many seats you want to keep for every class, you looking at the highest class first, and you deciding, well, this is how much I'm going to keep for the highest class, and the rest goes for lower classes. And then you look at what remains, and then the second highest, you decide the seats for them, and then the rest goes for the lower, and then you decide for the third highest class, and so on. So this is essentially this nested means that instead of deciding, if you have more than two classes, instead of deciding separate for each, you're always deciding highest versus the remaining ones. We'll have a picture on that in the MIT slides that I will show later. Okay, so two classes, and yes, we have to decide where we draw the line. So capital R and small r will be the revenues. So capital R per seat from the business passengers, small r per seat from the leisure. And we assume those are given. Those are the prices. So returning to our problem statement, we have answers to some of the bullets here. So overall capacity is 100. The prices are capital R and small r. Demand forecast. So what does it mean that we have, or that we want to have, the demand forecast per class? So here is our model. we will assume that the leisure demand is large. The price is so small that if you want, you can fill all the seats with leisure passengers. Okay? This assumption is a bit non-standard, so I'm also trying to connect to other places, the book, the MIT course, and many other places where you may learn about revenue management. Of course, in reality, you can also assume that the leisure demand is bounded and has some distribution and so on. But I'm trying to come up with the kind of minimal, what I call minimal non-trivial problem. So the simplest problem statement that still makes sense. And our problem statement will still make sense, will still be non-trivial, and we'll have a solution. But the simplest thing to assume is that for the leisure, we know that if we want, we can get all 100 seats filled with them. And now the interesting part, and this is where the question comes in, is that we don't know the business demand for sure. If we did, of course, we would have sold as many as the business wants, and then the rest goes to the leisure. But the business passengers demand will be a random variable. We don't know how many will come. But we have the distribution of it, and we'll see what I mean by that. How this distribution is obtained? Well, it could be estimated from historical bookings. I'll have it on the next slide referring to your probability course. Or it can be modeled, and we will have this demand modeling separate lecture. But yes, here is one possibility of how the demand or the distribution for the demand of the business passengers can be obtained. I'm sorry if it's not if the resolution is not good, at least not good on my screen. You don't have to read it, and in fact, this refers to a problem that you might have had in your probability course. So Mikael Hornquist sent this to me when we coordinated with him. That's what he teaches and what I teach in TNFL 07. He said, "Oh, you teach that," so he came up with this problem. This is really about the estimation of the number of business passengers on a certain flight. Frankly speaking, I'm not sure how to solve this problem. I didn't have to do that. You had to do it. But anyway, it just shows you some possible connection to what you might have seen earlier, a way to estimate the distribution of the number of business passengers. So in somewhat more technical terms, what does it mean that we are given the distribution of a random variable y? Well, it means that we know the cumulative distribution function of y. And here is the definition for the distribution function. So we will consider, mostly we will consider variables that take only discrete or integer values, 0, 1, 2, and so on. But very generally, the distribution function is a function that for every number k tells you the probability that your random variable will be smaller or equal to that number. So that's the definition. So as I said, I'm sorry, I seem to have lost the annotation tools. Zoom has been changing security settings, but hopefully you see my mouse. Well, anyway, that's the definition of the distribution, cumulative distribution function. So there are a few other functions that are associated with probability distributions. So something that's called probability density function for a continuous random variable y. Well, this probability density function shows you the probability of the random variable being sandwiched between two values. So this probability is given by the integral of the probability density function. And essentially, the probability density function is the derivative of the cumulative distribution function. For discrete random variables, there is something called probability mass function. And this thing probably is the most natural of all the functions. It really gives you the probability that your random variable is equal to a certain value. So here on the left bottom figure, you have an example of a probability mass function. You have a random variable which can take values from 10 to 14. And it says, well, with probability 1/9, it will be 10. With probability 2/9, it will be 11, and so on and so forth. It gives the probability for the random variable to assume certain value. And here on the right picture, you have the cumulative distribution function for this random variable. I guess O is the random variable, so this is not 0. I just took this picture from somewhere in the University of Kansas. So this is the cumulative distribution function, the probability that your random variable will be smaller than certain value. For instance, the probability that your random variable will be smaller than 12 is 2/3. The probability that it will be smaller than 13, well, something else here between 2/3 and 1, and so on. So this probability mass function is something showing the probability of the random variable assuming different values. Couple of examples. So we have 3 minutes remaining. I think we'll go over this first example, and then we'll start the next lecture from the second example, when I will also switch to my tablet and do some annotations and some writing. But before the break, maybe you can look at this random variable. So this random variable is a discrete random variable. It can be equal to 0 or 1. And here is its distribution function. The probability that y is at most 0 is 0, and the probability that y is at most 1 is 1. And my question to you is, what can you say about this random variable? If you want, you can answer in the chat. If I remember correctly, if I did teach this lecture in your class, there were some students that were able to give the answer back in Mikael's course on probability. Anyway, I'll leave you with this puzzle, what kind of random variable this is for the break. Okay, I see somebody. Okay, no, so I got a chat, but that's a private question about homework one. I answer it during the break. Let's break now and reconvene at 2:15.